We're going to cover two sections today, sections 5.3 and 5.5. And the first thing we have in section 5.3, a couple theorems. First one is theorem 5.9. I'm going to read the words to this one and then we'll draw a picture of it to show you what this one's telling us. Theorem 5.9 says if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. Here's what that means. If we have a triangle, and we'll put some sides on here. We'll say this side is 3, and we'll say this side is 7. Then what we can do is kind of trace backwards from there. If you go across from these two sides, the angle across from the bigger side, that longer side, this angle is going to be bigger than the angle across from the shorter, or the shorter side. This angle is going to be smaller. So we can use the sides of the triangle to put the angles in order, from largest to smallest or smallest to largest, whatever they ask us to do. So again, if you've got your two sides here, the side across from the longer side, or the angle across from the longer side is going to be bigger than the angle across from the shorter side. That one will be smaller. And then we can also do it backwards. This is theorem 5.10. With theorem 5.10, we're going to be given the angles, and then we're going to work back. I'll read the words to it first, and then we'll put some things in here. It says if one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. So again, let's put a couple angles in here. Let's say this angle is 80 degrees, and we'll say this angle over here is 50 degrees. So you've got a bigger angle and a smaller angle. You can do the same exact thing we did. If we follow across from that bigger angle, the 80-degree angle, if you go across, that side across from it is going to be longer than the side across from the shorter angle, or the smaller angle. This side's going to be shorter. Both theorems 5.9 and 5.10, you can use both of those to organize the sides in order or the angles in order based on the sides or the angles that are given to you. All right, let's show you a couple of examples of how this is going to work here. We'll call this first one letter A. This first one, they're going to give us a triangle. They're going to give us all three sides on the triangle. We're going to have an 8.8, a 7.5, and a 9.1. Let's call it triangle ABC. And then they're going to ask us to list the angles in order from, we'll go smallest to largest. And you'll kind of have to watch your directions on these. Sometimes they'll go largest to smallest. Sometimes they'll ask for smallest to largest. This time around they want smallest to largest. So taking a look at our picture, we'll start with the smallest. The smallest angle is going to be across from the shortest side. Shortest side on your triangle here is 7.5. If we follow across from there, you've got angle C. Angle C is going to be the smallest angle in that triangle. We're going to work our way up to the largest, so let's do the largest next. The largest angle is going to be across from the longest side. Longest side in this triangle is 9.1. If you go across from there, you have angle A. That's going to be the largest angle in the triangle. And then the side that fits in the middle, 8.8. If you go across from that, you're going to have angle B. Angle B is going to fall in the middle of those two angles. So if you put those angles in order from smallest to largest, you got angle C, then angle B, then angle A. All right, now that's doing it with the when they give you the sides. We can also do it where they give us the angles. So let's do one of these. All right, this time around we're going to give you a triangle. We'll go with some different letters here. Q, R, and S. And this time around they're going to give us two angles on the triangle. We're going to have a 45-degree angle here and a 55-degree angle here. And this time they're going to ask us to list the sides in order. And let's see, this time let's go longest to shortest this time. Again, you'll just have to watch the directions, whether they want longest to shortest or shortest to longest. This time around, we're going to do longest to shortest. Now, with this one, there's a little bit of work you have to do prior to putting them in order. We're missing one angle up here. So the thing we have to remember is if you add up all three angles in a triangle, you're going to get 180. 45 plus 55 is 100. If you take 180 minus 100, you're left with 80 degrees for this top angle here. And then once you have all the angles in order, or all the angles put in there for you, now you can go ahead and put the sides in order from longest to shortest. So longest side is going to be across the biggest angle. The biggest angle is 80. If you follow across from there, RS would be the longest side. I'm going to go to the shortest next. Shortest side is going to be across from the smallest angle. The smallest angle is 45. If you go across from there, you've got QS. That will be the shortest one. And then the middle angle here is 55. If you go across from there, you've got RQ. RQ is going to fit in the middle. From longest to shortest, you have RS, RQ, and QS. So these are the two main examples of how they're going to have you do this. There is a third option that will show up occasionally. I'm going to show you one of these. And this time we're going to have two triangles kind of joined together. We'll call this one letter C. I'm going to put a triangle on top and then another triangle on the bottom. And I'm going to label these sides, or these vertices C, D, E, and F. And then we'll kind of do it like we did before. The last problem we just got done doing here. One of the angles, there's going to be a 40. Other angle here is going to be a 60. On the bottom triangle, they're going to give us a 65-degree angle here and a 70-degree angle here. And the directions are going to tell us to order the sides from least to greatest. And when we do this one, we're going to start like we did on this last problem we just did. We're going to take one of the triangles, fill in the missing angle. So on this top triangle up here, you've got two angles, 40 and 60. Those add up to 100. All three angles in a triangle add up to 180. So if you take 180 minus 100, you're left with 80 degrees up here. Then I'm going to go to the bottom triangle and do the same thing. Bottom triangle, you have a 65 and a 70. Those add up to 135. If you take 180 minus 35, you get 45 for that third angle on the bottom, angle F. Now, what I'm going to do is do the triangles one at a time. I'm going to take the top triangle first. And on that top triangle, I'm going to put them in order. We want to go from least to greatest, so I'm going to put the shortest side on the top triangle down to the biggest side. So if I go to that top triangle, the shortest side is going to be across from the smallest angle. 40 is your smallest angle, so the shortest side is going to be CE. And then we'll work our way up. 60 is the next biggest angle. Across from that, you have CD. And 80 is the biggest angle. So across from that, you have DE. That's going to be the longest side. There's the sides of that top triangle put in order from least to greatest. Now let's do the same thing with the bottom triangle. Bottom triangle here, we're going to go again from least to greatest. Smallest angle is 45. Across from that you have DE, so that's going to be the shortest side. 65 falls in the middle. Across from that you have EF. And then your greatest side on this one is going to be across from the biggest angle, which is 70. Across from the 70 you have side DF. And then when you take a look at those two triangles, they share this side DE. So this DE right here, that is going to be the same side on the two triangles. What that means is that side DE is fitting right in the middle of these sides here. So if I want to go from least to greatest, the smallest one we're going to have is CE. CD is going to be the next biggest. DE is going to fall right in the middle. And then the ones that are bigger than DE are EF and DF. So that DE falls right in the middle. Those two were the same. These two are smaller than DE. These two are longer than DE. So these two go above DE, these two go below DE. And there's your order from least to greatest. CE would be the shortest side, DF would be the longest side. So this is the answer we're looking for right here. Okay, that takes care of section 3. Now let me flip over to section 5. There's just one thing in section 5 that we do. And I'll put 5.5 here just so we know we're starting the new section here. And the one new thing in 5.5 is called the triangle inequality theorem. And once again, what I'm going to do with this, I'm going to read through the words and then we'll draw a picture of it. Theorem 511 is what this one is called. It's the triangle inequality theorem, theorem 511. It says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So if we add any two sides of a triangle together, they have to be bigger than the third side. So let's draw a triangle. And on that triangle, let's label the sides A, B, and C. And once again, what the triangle inequality theorem said is it says if you add any two lengths of the triangle together, they will be bigger than the third side. So if I add any two sides of the triangle together, let's add A and B together first. If I add those two sides together, they're going to be bigger than the third side, which would be C. If I decide to add A and C together, those two have to be bigger than the third side, which in this case would be B. And then our other option is to add B and C together first. If you add those two sides together, they have to be bigger than the third side, which in this case would be A. That's your triangle inequality theorem. If you add any two sides of a triangle together, they have to be bigger than the third side. Now what we're going to do with that is use it in an example where they're not going to give us a picture. They're just going to give us the lengths of the sides of a triangle. So it's going to look something like, the directions are going to say, is it possible to form a triangle with the given lengths? And then they're going to give us, let's see, we're on letter D, they're going to give us 3 lengths for the sides of the triangle. So let's do this one. We're going to have one side be 6 meters. One side's going to be 8 meters. Third side's going to be 14 meters. We want to figure out if it's possible to form a triangle with those 3 side lengths. Then if you go back to your triangle inequality theorem, we're just going to go through this. We're going to add 2 sides together, make sure they're bigger than the third. If that is the case with all 3 sets of sides, then it is a triangle. If any of those inequalities does not work, then we cannot form a triangle from those lengths. So let's start it off. I'm going to add the first 2 sides together. 6 and 8. If we add those together, they have to be bigger than 14. If I add the last 2 sides, 8 and 14, those have to be bigger than 6. And if we add the first and last one together, 6 and 14, those have to be bigger than 8. And those are my 3 inequalities. Now we just go and see if that's a true statement or not. 6 plus 8 is 14. 14 is not bigger than 14, so this is not true here. This one would be false. The others are going to end up being true. 8 plus 14 is 22. That is bigger than 6. 6 plus 14 is 20. That is bigger than 8. So these two work, but since this one does not work, these will not form a triangle. So our answer here would be no. And if they want an explanation, here would be your explanation right there. 6 plus 8 is not bigger than 14, so that would not form a triangle. Let's show you one that will form a triangle just so you can see the difference. This time our side lengths are going to be 8, 15, and 17. And then we'll go through the exact same process. We're going to put together our three inequalities, see if they're true or false. So we're going to add any two sides together. They have to be bigger than the third. The first two sides are 8 and 15. Those would have to be bigger than 17. If I add the last two sides together, 15 and 17, those would have to be bigger than 8. And the first and the last one would be 8 and 17. If we add those together, they have to be bigger than 15. Then if you go through these inequalities, they're all going to end up being true. 8 plus 15 is 23. That is bigger than 17, so that's true. 15 plus 17 is 32. That is bigger than 8. So that's true. And 8 plus 17 is 25. 25 is bigger than 15, so that is true. So our answer here would be yes, this would form a triangle. And if they ask you to explain why, you'd just be able to go up here to these three inequalities and say that all three of those inequalities were true, so it would be possible to make a triangle from those three lengths. Okay, and that is it for section 5.